All right, welcome to Booth Ross and the Joy of Mathing, edition 12.4, Parametric Equations. So this is going to veer off from polar equations. But there are some similarities and so on. But parametric equations are pretty important to understand. So a parametric equation, so typically we define y in terms of x, like I stated right here. Parametric equations are where we introduce a third variable called a parameter. So you might have x in terms of f of t and y in terms of t as well. So both of these functions, f of t and g of t, are called parametric equations, where t is the parameter. Now, parametric equations I've seen often in life where they use t because t represents a time. And they have to use that time element to map both the x, the horizontal, and the vertical distance to help them figure out real-world problems. So, super helpful. So, we're going to go ahead and graph. When it comes to graphing parametric equations, I want to show you how to graph it without seeing the rectangular equation. You kind of have to do that anyway because you have to show the direction that the equation is going. The direction of the line, curve, or whatever is super vital when you graph these. So you actually don't convert it to rectangular first. You just go ahead and make a table. Now this is going to be a crazy looking table because we're going to have it in terms of t, x, and y. But when we graph, we're only going to be looking at these values. Okay, so our t value, they'll often give you some parameter restrictions on our parameter. So we're going to go between 0 and 4. So I'm just going to go ahead and plug in everything between 0 and 4. And then I'm going to plug them in to each equation. So to find x, for this first one, I'm just doing 2 times 0 minus 5, which is negative 5. Then I do 2 times 1 minus 5, which is negative 3. In fact, since the slope is 2, I'm just going to go up by 2 every time. So negative 1, 1, and 3. So same idea with y. If I put 0 in, I get negative 2. Since this is a line, my slope will be 3, so I'll go up by 3. So negative 2, 1, and then 4, 7, and 10. Okay, so the highlighted part is what I'm actually going to graph. And it's important to know what we start out with. So I'm going to highlight our first point when we start graphing. So we got negative 5, negative 2 right here. And I'll highlight that as our starting point because that's important. And then negative 3, 1. And then negative 1, 4. And then 1, 7. And then 3, 10. Well, it kind of looks boring if you really look at it. It just is a straight line. And it begins right here. I'll highlight the end point. So there's the end point. Now the direction, though, since it begins at the yellow, you have to show little arrows to indicate the direction, like so. Say it's going this upward and so on. All right, so let's get to the fun part where we convert. Converting just means, or converting it to a rectangular equation just means that we need to solve for t in one of these equations and do a substitution so that we have the equation in terms of x and y. So you can choose whichever one you want. I'm going to go ahead and say I'll use the x equals 2t minus 5 equation. So I'll add 5 and divide by 2. And then I'll go ahead and plug that in to t for the y. So I get y is equal to 3 multiplied by x plus 5 over 2 minus 2. And I'll clean that up a bit. So we've got 3x plus 15, all of that over 2 minus 2, which is the same thing as 3 over 2x plus 15 over 2 minus 2, or our final answer of 3 halves x plus 11 halves. I really wanted to simplify it down a ton just to show you. 11 halves is 5.5. Notice this is a graph, or a line, and then a slope of 3 halves going up 3 over 2. And you'll notice that actually fits right with our graph. So it's a great way to check to make sure you graph something right. So that's it. It's pretty easy. Let's do a couple more. Let's go ahead and graph this one. Same idea. I'm going to go ahead and make my fancy table. I've got my t, my x, and my y. And I'm going to go ahead and pay attention to what parameters they give me. So it just says it has to be greater than or equal to -1. So I'll start with -1, 0, 1, 2, 3. I don't know. Go as far as you want until you see enough of the graph. So let's go ahead and start with x. X is just t plus 3. So -1 plus 3 is 2. 0 plus 3 is 3. We're just going up by 1 every time. So 4, 5, 6. And we're going up by 1 because the slope was 1. So then let's go to this one. If we plug in -1, we get 0. If we plug in 0, we get the square root of 1, which is 1. If we plug in 1, we get the square root of 2, which is approximately 1.4. If we plug in 2, we get the square root of 3, which I want to say it's like the 1.7. I just double checked. Yep, it is. Okay. And then this one will get the square root of 4, which is 2. Okay, so decimals are okay. It's not a problem. We're just going to have to graph decimals. It's going to be great. So let's go ahead and plot. Remember, we're only focusing on these values. So we've got 2, 0 right here. We've got 3, 1. Now I'm going to highlight that because that's our starting point. So 3, 1. I got 4, 1.4. I got 5, 1.7, so just a little higher. And then I've got 6, 2. Now notice this one does not have an endpoint, so you'll just continue it on, but you still need to show some direction in the middle of the graph so we know the direction of this graph. Let's go ahead and convert this. It'll probably be easiest to go ahead and solve for t with this equation. So t, if we subtract 3, is just x minus 3. And then we can plug that in for y. So y is going to be the square root of x minus 3 plus 1, or I'll write it down here. Y is the square root of x minus 2. In fact, if you look at this graph, that is a square root graph, just shifted to the right 2. So, sweet.